Thank you very much for joining the workshop today. Today we're going to go over some labs to talk about golden paths that you might implement in your platform. I think it should be good content and some interesting stuff to think about and digest. Today I'm joined with three other folks from Google. My name is Benjamin Good. I'm a cloud solutions architect. I'm joined by Ameenah and Shobit, who are also cloud solutions architects on my team, and Gary, who's an outbound product manager on GKE. So great group of folks today to work through some labs. Today, what we're going to do is we're going to go through getting set up and just some logistical kind of stuff. I'm going to do a little bit of intro and background on platform engineering. Just that'll give us a little bit of time to level set on some terminology and background as we go through the labs today. From there, Ameenah is going to go through some developer experience lab. Shobit is going to take us through a lab on automating secrets rotation, and then Gary is going to take us through a lab on how we build scalable platforms with GKE, and then I'll come back and we'll wrap it all up. So let's dive in. So everyone should have gotten an email prior to today letting them know to go to explore.quicklabs.com. There you'll want to create an account using the email address that you registered for this workshop with. That will get you access to the labs in the classroom there. Chrome browser works great for these labs. You're also going to want to have incognito mode for when you're actually running the lab. It makes logging into the cloud console and that kind of stuff easier. So if you haven't done so already, go to explore.quicklabs.com and get registered for an account using the email address that you registered for this workshop. Okay, when you log in to QuickLabs, you should see if everything is working correctly, and I added you to the labs and all that kind of stuff ahead of time correctly. You should see this PlatformCon 2025 course that was scheduled for today. When you click on that, you should see 3 labs. These labs are actually about 3 hours worth of labs and learning, and we're condensing it down to about 90 minutes. So what we'll do is we're going to do a quick demo of the first 2 labs, the automating password rotation and the developer experience. We invite you to come back to the classroom, go through those labs on your own. There's step-by-step instructions that guide you through those materials. And then you can do all the learning there. The manage multi-cluster workloads at scale with GKE fleets and teams. Gary's going to run that one with everyone today in the workshop. So we're going to condense down 3 hours worth of labs into this 90-minute workshop by doing the first 2 as a bit of a demo and run through of the overarching learning there, and then hands-on activity of actually doing fleets and teams management. If you do not see this scheduled course when you log into QuickLabs, there's a breakout room called Help and Support. Shobit is over there right now and can help you get added to the classroom, sign into QuickLabs, those kinds of things. When I'm done with my portion, I'll join that breakout room and help folks as well. But if you do not see this box, it says PlatformCon 2025 with the little purple header, go to the breakout room and Shobit can help you. When you go into the lab that we're going to do together today, you should see a screen that looks something like this. It'll say manage multi-cluster workloads at scale with GKE fleets and teams. There will be a button that says start lab. When you click it, it'll turn red. It says end lab. One of the things that you'll want to do is there will be a button there when it's all set up and running. It says open cloud console. That's where you want to use the incognito window. So right click on that and say launch open link in incognito window, and that will make things easier from a managing your session and logging in and all that kind of stuff perspective. So that's the getting set up part. So if you have any questions, need help, please go to the breakout room, help and support. Okay, so one of the things that we wanted to do before we dive into the labs is just to level set on what, when we talk about platform engineering at Google Cloud, what do we think about and how do we think about it? And then how does that inform us as how we, want to help you all in your platform engineering journeys? So on the slides right now, you see the couple definitions of what a platform is from ThoughtWorks and team topologies. And we think that these really encapsulate what an internal developer platform is. It's really a set of tools and APIs and services that make for a curated developer experience on your internal developer platform. And the goal of that platform is to reduce cognitive load and make the engineers, in your organization more autonomous, and ultimately, help them deliver products and services at a higher pace. We also think about platform engineering as a type of engineering. So similar to how software engineering in general is focused on creating value for our customers and our end users, that is an engineering practice. You do things in there specifically, to deliver that value. Site reliability engineering is also an engineering practice, but with a different view or a different lens of where it's focused. In that case, you're interested in incident management, building the tools and supporting engineering teams from a monitoring and metrics perspective, making sure that capacity is available. So like those two things are specialized forms of software engineering, we think of platform engineering similarly, where we're applying software engineering practices, but with the purpose of creating that curated product and set of experiences and services for our internal engineers and users. And like I said, aimed at reducing the overhead and the cognitive load associated with doing these other engineering practices. So when we think about it, we think that there's a few principles that we want to anchor our platform engineering practices on. And I think this is a theme that we have generally across the platform engineering community. That is, the platform is a product. We want to make sure that it's treated like a product. There's product managers and those kinds of roles in the team to support the platform from that perspective. The platform engineering team needs to be a blend of engineering disciplines. So you need to include software engineering practices, SRE practices, other specialized practices like database administration or container administration, those runtime level things. And really what we're aiming to do is to build out a set of golden paths that our internal users can then exercise to make their lives easier and better. And that's what we're going to focus on today. So we're going to go through in the first two labs some examples of golden paths aimed at improving the developer experience, and the other one aimed at how we might automate password rotation inside the platform. And then Gary's going to take us down into how we can use GKE as this foundation for building a scalable internal developer platform that we can then build these golden paths on and run our applications on top of. So we hope to bring this picture together today through the labs. So just one last quick slide here to make sure we're all on the same page. When we talk about a golden path, we're talking about something that streamlines the developer experience. And that could be something as simple as documentation of this is the way to go about accomplishing task XYZ. Or it could be something highly automated that, you go click a button or hit a command line interface. and then something happens, comes out of there. And that can be the golden path as well. But really, what we're looking to do is to provide developers autonomy, such that they can go about getting their jobs done more efficiently, and bringing in the opinionation of our internal organization, of our organization, not necessarily Google, but our platform, into those golden paths. So that's the background that I wanted to share and make sure we're all level set on. Again, I'll make one more call out here, which is go to explore.quicklabs.com. Make sure you see the classroom. If you don't, go to the help and support breakout room, and we'll get you going over there. At this point, we're going to dive into the labs. And as you go through these labs, and at the end of the day, this is pretty cool. You're going to get a badge on Credly that says you did this workshop. You now have, this extra level of understanding on golden paths on Google Cloud. And we have this cool little badge that looks like a little golden path as well. So I think that's pretty cool. So you'll get an email following this that says to accept your badge. And then please share that on your LinkedIn profile and all those other things. So at this point, I'm going to turn it over to Ameenah to go through developer experience, and I'm going to jump into the help and support room to help you all out. Thank you.
All right. So I hope you all can see my screen. Thumbs up. Anyone? Gary?
I see it.
Yeah, great, great. Okay, so I'll be going through the developer experience lab. Um, this lab, what it is it splits two different personas, one being the platform engineer, and then the other being the developer. In each of these tasks, you can see the role that you'll be playing while executing the steps. The idea is you go with the platform engineer, you'll log in first and you'll set up the environment for the developer. So this includes GKE clusters, CI/CD pipelines. We're using in this lab cloud build as well as cloud deploy. Just for the sake of time, I've already done the platform engineer steps. So if I kind of jump down here to this developer, this is the first step in the developer role. And this is what was built through the steps that I kind of skipped through just for time's sake. Like I said, we have the GKE cluster. We have cloud deploy, deploying new updates to that cluster. And then we have the pipeline. So we're using like a repository, Git repository, not a Git repository, but a source repository. And updates to the code will trigger a build and it will deploy to GKE. At the end of the task for the platform engineer, what you'll end up with is this little website with this white background. The change that we're going to make as a developer will be to create a dark mode. So basically changing the white background to black, just to kind of see the contrast between the two. So when I go into the shell, what you'll do is that you'll actually log into the developer account and set up your credentials and environment variables. You'll then clone the repo. I've already done this just for time's sake. And then you'll actually go in and update the index file. So if you see boxes that are in black, that's just for viewing purposes. This is a before state. You don't want to copy this. Anything that doesn't have a copy button here, don't copy it. But you want to copy the new dark mode. And what you'll do is you'll go into this file that opens and you'll paste this here. What we can do is fix some formatting a little bit. Go back into the terminal after you make the update, and then you'll just make the commit. So it takes about a minute for it to trigger here. If you want to see the different builds, I've done a couple different things here, but what you'll see is that if you go into the cloud build history, you'll see kind of the spin in progress for it to actually trigger cloud deploy to deploy the image. Another thing that you'll want to wait for is, so after this actually runs, we're using cloud deploy to actually deploy it. So there'll be two other processes that need to complete. Once everything is actually deployed, what you want to do is you want to test out the changes. So this will get access to the cluster, so you can get this endpoint that you'll visit. So what that'll look like is this, and you should be able to just click on this, right? So this is the same thing as this here. And once all of our processes are done, what you should be able to do is you should be able to refresh this page a few times and actually see the update. It usually takes a while, especially because the way it works for Canary deployment is it looks at previous history of traffic in order to understand what 50% is. In this case, because it's a new application, you won't, like, it doesn't know what the 50% is. So you'll probably have to refresh around like maybe 10 to 15 times, hopefully a little less, so you can actually see the updates. And I'm just going to try to refresh it. I've run it already. So you just a couple times, and you see we have the black here. If you refresh it a couple more times, what you'll see is it's trying to understand the pattern of traffic to understand what 50% is. So you can just kind of go back and forth between seeing the Canary deployment of each version. So once you're actually satisfied with the changes, so we're able to see the black mode and everything looks good, what we're going to do is we're going to actually go to cloud deploy, and you're going to progress the pipeline. So that's basically pushing it so that the black or the dark mode is actually the default. So you'll go into cloud deploy, you can click on the name, and what you'll see is that in cloud deploy there's this let me scroll down a little bit so you guys see it. There's a bunch of different things here to talk about. I deployed it a couple of times. That's who that is. But what you can do is advance to stable. So the advance to stable, that's going to go ahead and remove the 50% canary. So once this releases, we'll get just hopefully the black mode. Let me go to white mode so we can just see it change all the way. And if you want to actually see the progress, what you'll see here is another process will start here, and it'll circle around for a little bit. But once it gets stable, what we should see is that this should be stable and deployed in green. When going through these labs, it's important to kind of wait for all the build processes to finish. Otherwise, you won't be able to see kind of the results as quickly. So let's let this finish deploying. And while this goes, one thing I do want to tell you guys about is that part of the platform engineer's role is to change it from a standard just deployment to the canary. So you will see an error because what happens with cloud deploy, if we go to GKE really fast, what it's doing behind the scenes is creating a copy for the canary. So this is our current version, our original version, and this is our dark mode version. And this is what allows it to actually switch between the two versions using cloud deploy. But when you initially start, you won't have this. So you'll get an error saying that this doesn't exist because you're switching from just the standard update to just the Hello World app to needing another app. But you can just progress beyond that. Don't let that stop you. So let's see if it advanced to stable. I think this is from the other process that I just started, but let's go to Now, if we refresh it a couple times, we'll see that the canary's gone. And now you only see the dark mode. So that's how you know you've completed the task. If you can refresh a couple times and it's still in the dark mode. Now, that's it for that lab. You will complete it after that, and I'll pass it to Shobit to go over his rotation, password rotation.
Awesome. Thank you, Ameenah. So let me go ahead and start my screen share. All right. So are you guys able to see the lab on the screen? I'm guessing yes. Oh, perfect. All right. So hello, everyone. My name is Shobit Gupta, and I'm a solutions architect at Google Cloud. In the next 10 minutes, I will be walking you through a lab that helps you design an architecture where you can rotate the secrets automatically in any underlying system. During the course of this lab, we will be wearing two hats. The first one will be the platform engineer hat. And what we are going to do with that is that we are going to design a generic reference architecture to rotate the password. And then we will dive a little bit deeper and design a specific reference architecture to automate the password rotation in Cloud SQL database. Then we will put our developer hat on and we will then invoke the password rotation, or you can also call it as invoke the golden paths that were provided by the platform engineers. So let's jump right in. And I think you are already aware that I'm not going to run through this lab. I will just give you a walkthrough of this lab and you will receive a link separately and it will be open for you. You can, after the session, go ahead and start play around with the lab and you can complete it with your own pace. So when we talk about rotating the password in any application, there are mainly three major steps. The first one is that you rotate the password in the secret manager of the application or a database or any system that you are targeting. And then you go and change the password in the underlying system. So let's say if it is a Cloud SQL database, you change the same password in the database as you changed in the secret manager. And then you may also need to restart some of the applications just in case if you want them to source the latest password so that you can avoid the failures. So these are the major three steps that you would go about when you are architecting how do you rotate the passwords. So I will scroll down a little and bring up this generic reference architecture of rotating the passwords. On the left-hand side, what you see is a workflow initiation. So what triggers the password rotation or what triggers the golden path to rotate the password? It could be a Cloudbit trigger, a Jenkins pipeline, a GitHub commit, a Cloud scheduler, or any other tool of your choice. And what it does, it actually writes the message to a pub/sub topic that contains the metadata of what password needs to be rotated. So I'll pick on the example of Cloud SQL database. If you were to rotate the password for Cloud SQL database, it will publish a message to pub/sub that contains the location of the database, the name of the database, the instance ID, and the user. Now, when this message arrives on the pub/sub topic, a Cloud function is continuously on the lookout for that. As soon as the message arrives, it picks up the message, it parses it, and it decides what needs to be done and in what system. So again, it will decide that this password needs to be changed for this user in the given database. And then it goes and does the actual password rotation. It goes to the underlying system, retrieves the password there, then comes back and change the password in the secret manager or HashiCorp Vault or any secret management system that you're using. And as the final step, you can also broadcast that the password has been rotated for a given system to the downstream applications. So if there is any dependency or a cleanup or a restart that the other applications might need to do in the event of a password rotation, you can take care of that by publishing a message to a pub/sub topic. Now, as a platform engineer, you will be writing the infrastructure as code automation to create all these resources and deploy them. And as a developer, you will be invoking this workflow that will rotate the password for you. Now, I'm going to go a little deeper into a specific reference architecture for rotating the Cloud SQL database password. So here, what we are going to do is we will have a cloud scheduler. This is the workflow initiation part that we saw in the previous picture. The cloud scheduler will be scheduled to run on the first day of every month and sends a message to PubSub topic. This PubSub topic receives the message, parses it, and passes it on to the cloud function. The cloud function acts on that message, and it goes and updates the secret in the secret manager. Then it goes through the VPC connector uh, and the private IP and changes the password in the underlying database. And here I'm skipping the last step, which was to notify the downstream systems that the password has been rotated, because I mean, this is just for a reference implementation, but you can do whatever thing is better for your organization based on the security practices that you have been writing. So I have already deployed the reference architecture, which means all the resources that we saw in this picture are existing in a Google Cloud project. I'm going to walk you through those resources now, and then I will trigger the password rotation, and then we will see that the password has been changed in the underlying database. So I'm going to change my screen. I hope you see the Google Cloud Console here on this screen share now. So we have already created a Cloud SQL database. It's already on the screen, but I'll still go and pull it up afresh. So the Cloud SQL database is named Cloud SQL for Postgres, and it is a private database. You can connect it over the private IP. The password for this SQL database has been stored in Secrets Manager. So if I go to Secret Manager, there is a secret ID called Cloud SQL password. If I click on it, I will see that there are two versions. That is because I have already rotated this password once in order to prepare for this session. So what I'm going to do is I'm going to take this password and try to log into that SQL database just to make sure that everything is working before we start even rotating the password. So I'll go here and open the Cloud Studio, and it's already connected. That's because I just did that before this meeting started. So we will assume that we are able to connect to the database. Now, there is a Cloud Scheduler that we created, which is the workflow initiation part. This Cloud Scheduler, as you can see, it runs on the first day of every month, and it publishes a message to a topic named, a PubSub topic named password rotation topic. Let's take a look at this PubSub topic. The PubSub topic has a subscription, and this subscription is to push the message uh, to the cloud function. And if I go into the schema, we have also defined what kind of schema should be present in the message arriving to this topic. And as you can see, for the Cloud SQL database, we have requested a secret ID, which is the ID of the secret manager, the name of the instance, the database user, and the database name. And the message should contain all these details in order for the cloud function to be able to depict what password needs to be changed and where. Then finally, we are going to take a look at the cloud function that is going to rotate the password. So the cloud function name is password rotator function. If I click on it, you can go to the triggers tab and see when this function gets triggered. So you'll see that this is receiving the events from this topic, the one that we just saw, and it gets triggered when a new message arrives on this particular topic. If you want to look at the code, what this function runs, we have a Python code that just goes and rotate the password for us. So as in platform engineering, you will provide all these resources through IAC that gets deployed into a GCP project. Now, as an application developer, I might need to rotate the password. So what I'm going to do is invoke this workflow so that the password gets rotated. So I'm going to go to the Cloud Scheduler. And I will click on it and I'll do a force run. Now, please note that it is supposed to be running on the first day of every month. This is completely at your choice. If your security team wants you to do it every 15 days, you can change the schedule based on your requirements. All right, so The scheduler has run. Let's go and check if the secret manager has a new version for that particular secret. It's going to take a few seconds for it to complete. Oh, yes, there was the third version available here. So as you can see, a new version of the secret has been available. So under the hood, what has happened, that cloud function, that cloud scheduler ran, it sent a message to the PubSub topic with the details of the database that required the password rotation. As soon as the message arrived to that PubSub topic, a cloud function got triggered, pulled that information, it figured out what database it needs to rotate the password on, went there and rotated the password, and then changed the secret manager to reflect the same password. So I'm going to copy this new secret and try to log into the database. This time it asks me to provide the credentials. That's because the password has been changed. And I provide the version 3 of the password, and it lets me in. So now I'm able to log into the Cloud SQL database with the changed password. So that's pretty much from this lab. And I mentioned earlier, you will get a link to try this lab on your own. And please do try it and let us know if you have any feedback. With that, it brings me to the end of this lab, and I will hand it over to Gary.
All right, great, thanks. That was pretty cool. I guess we'll try to we'll attempt to actually do one of these labs live. So yeah, Gary Singh, one of the PMs for GKE. So I guess yeah, hopefully everybody's set up. Ben's here. If not, we got support. If not, but let's get to it. So hopefully everybody. Let me share my thing here first. Share to main session. Share. This one. All right. So I think we sort of did this earlier, but hopefully you already did that. But I'll just go through it as well. So you should see your scheduled course. Hopefully you did this, as we said earlier. Manage multi-cluster workloads at scale with GKE fleets and teams. We click on that. All right. So hopefully everybody sees this screen. And then, all right, we're all going to, and I'm going to do this. I'm going to do this in real time with you all. So we'll walk through this. But I'm going to hit Start Lab. I think it takes like maybe. It should tell us, but like a couple of minutes to provision that lab. So I guess I'll just check in, and I guess we really can't tell if how everybody's doing, right? But maybe while we so let's see here. We'll yeah, it says about 1 minute here. So let's let it sort of do that, but maybe just in the effort of having a little bit of fun, we can kind of walk through a little bit about what we're actually going to kind of, I guess what we're going to do in this lab itself. So I'm going to just share, let's check that again. All right, we're still good. I'm going to share kind of a different screen. So I think the whole point here of this, of really this lab is, in general, one of the big parts of, say, platform engineering or platform stuff with, especially with Kubernetes as being sort of that underlying infrastructure that you may build your platform on top of, is you're going to have essentially, hopefully, multiple development teams, and you're probably going to have kind of multiple clusters. And really, we want people to focus on the higher level things of the platform, things that were sort of shown earlier, like how do we build apps, blue-green, sort of that deployment, and how can we make it easier for you to basically, manage this infrastructure, which again may encompass, different teams, different clusters, et cetera. So one of the concepts that we've had in GKE for a while was this concept of fleets, and a fleet is really just contains a number of clusters. If you are into Google Cloud, hopefully some of you are, Google Cloud has these concepts of projects. So Google Cloud project can have clusters. And within a fleet, which is kind of in projects, you can divide things up by, again, teams, organizational boundaries, et cetera. One of the nice things about fleets is that it provides a kind of a cross-project view as well. So, all right, well, I'll finish that up, but hopefully you guys, so what we're going to get into is we're going to talk about how to kind of set up a fleet. And then we'll come back here and in between some of the steps that take a little bit of time, we'll delve into this. So hopefully everybody has a screen that looks like this, which just says, which means the lab's up and running. All your credentials are here. The key, Ben showed this earlier. I'm not sure if everybody was on. Basically, just right click on the open Google Cloud Console, say open this link in a new incognito window, and voila, you should be welcome to your new student lab account. You'll just click I understand. And all should be good. As I like to say, it's just a lab, so it's not even using your real name. So feel free to agree to those terms, since we set you up kind of as a student. So hopefully everybody's at this sort of step. So what we're going to do next, it's going to be a little tricky because I'll have to switch back and forth here, but so the goal, hopefully everybody, we can skip through this part. You can come back and read that. I kind of explained that. We'll scroll down to, once you've got the screen up here, let's scroll all the way down. So the first thing that we're going to do is, and by the way, this step is actually going to go away in about a couple of months. We're just building most of these features in, and you won't even have to enable the features this way. But for now, one of the things that we need to do is basically some of these features are part of our kind of enterprise feature. So what it really is talking about, oh, sorry, I got to go back to, so I got too many screens here. This tab here. So what you want to do is you're going to scroll down here. You should see, if you can see my screen, hopefully up there, you should see Kubernetes engine kind of in the left-hand menu. It definitely should show up. You're going to want to click on Overview. And then we're going to we'll just click on the sort of fleet dashboard here. And because we don't have fleet enabled, the instructions just tell you this. We're going to click on Learn About GKE Enterprise. And then because it's a free lab, if you are doing this by yourself in your own account, you can actually do a 90-day free trial. And again, in September, by the time the 90-day free trial ends, all these features will be just included in the base product. But for now, you'll just hit Enable GKE Enterprise. We tell you to enter a fleet name was part of the instructions. So if you were looking at it, I think we said call it GKE Enterprise Fleet over here. It's optional. You can name it. It doesn't affect the rest of the lab if you don't, but you'll want to click on this button here. And then we'll call this GKE. So all we're doing here is basically just setting up the basics of kind of our fleet that we're going to basically join everything to.
Gary, we have a question in the chat while this is doing the thing. Someone would like to know about the range of costs when deploying a multi-cluster GKE.
The range of costs
when deploying the multi-cluster GKE.
I mean, yeah. So in general, it doesn't call. I mean, for when deploying clusters, there's no difference between deploying one or more clusters. In general, you're really just paying for the compute. We do have control planes for each cluster, so there is a kind of a management fee for that. But there's no, you can just deploy as many kind of clusters as you want. The management fleet fee is kind of negligible. And then currently in this notion of managing multiple clusters, we did have a charge for managing multiple clusters. That charge is actually going away in September. And that was an additional, you can look it up, but there was an additional there was additional charge to manage multiple clusters. That's going to be going away soon. right. So hopefully, I don't know. Hold on, I got too many. I guess I got so many tabs going here on my screen. All right, so hopefully my operation was complete. So we're going to just close out of this screen, and then in the next steps, we're going to, I believe we're going to create some clusters. So just while you're here, it does tell you how to do this, but you just want to, if you don't see it, this is the Cloud Shell, which is pretty cool.
Here.
Terminal for, yeah.
I think you're sharing the wrong tab real quick. I only see the lab.
Oh, sorry, I'm back over here.
Much better, thank you.
Yeah, sorry. It was on the instructions. So we'll just compare. The Cloud Shell was up here in the top. Just click all the way through, authorize, yes, no. I don't know if this will pop up for you, but basically we're provisioning our Cloud Shell. So this is going to allow us, now we're logged into our Google Cloud account. So it has all the credentials and everything needed. You'll see, I'm just gonna, you guys can all, everybody can read the lab too, or I'll try to bring it back up here. Share this tab again. So we've created our fleet, and now we're essentially, oh, I guess you're supposed to check your progress. It doesn't really, it's always good to run this check your progress just to make sure you did everything correctly. We do actually let you continue with the lab, as well. So don't worry if you forget to do that. So we just covered this. We opened up our sort of Cloud Shell. And now what we're going to do is we're going to create, just create 2 clusters. Yeah, all you really want to do is cut and paste this command and then cut and paste this command. The nice thing that we're doing here is we're running this first command asynchronously. So it'll run in the background, and then we'll run the second command synchronously, so that we'll know when our clusters are created. So and we're just creating one that's kind of our autopilot mode cluster, which is our fully managed, where we run all the nodes and everything for you. And then we're creating a GKE standard mode cluster, where it's kind of a shared responsibility, where you have some responsibility for the nodes as well. So we'll just copy this here. We'll switch over here. Should run this. Hopefully everybody sees that. And again, feel free, by the way, to you don't have to just do what I'm doing. I'm just, I'm just kind of going through this for people who want to follow along. If you are super fast, feel free to run ahead and then just tag us if any issues sort of come up. So I've created my my first cluster here, and then I'll just create my second cluster as well. And this second command will actually not hang, but it'll run synchronously. So it's going to essentially create this cluster. Generally can take, depends on, the mood of Google Cloud on that day, but, anywhere from like generally 4 to sort of 6 minutes to sort of, create this. So we'll check back on this. Hopefully everybody's done that. So while we're doing that, we'll go back and just talk a little bit more about sort of what we're going to do. So we've created a couple of clusters, and eventually we're going to register them to the fleet, as I was talking about, which is just a way of having a view across your entire cluster. Now we'll give you some time to explore around when you sort of do things in the lab, but one of the nice things about this whole thing is the sort of built-in dashboard. And you can see here, for example, what's happening here. We're looking at every cluster in the fleet. I actually have about 12 clusters in here. Apparently, 2 of them actually have errors. We won't check on those today. We'll have 3 teams, which we'll cover teams and team scopes a little bit later. And then we can actually even aggregate up the overall sort of cost for this entire fleet. So, maybe your production, your test, your sort of development. We're going to cover a little bit in terms of some of the core features. So we're going to talk a little bit about sort of policy. We have a couple of other interesting features as part of for platform stuff. One of them is this security features, which is kind of cool. We have this. We basically have a couple of things in there. One is like workload misconfigurations. We kind of have a set of best practices like things like you were running privileged workloads, you were trying to use host port, you were missing information, you were using bad port range. There's a whole bunch of them, and you can kind of see in here we're kind of giving you the overarching view of like all the concerns like in your entire sort of fleet of clusters. You can actually then go drill down into them. And by the way, we basically just kind of let these clusters run and sort of self-fix themselves because they're good for sort of demos. But now we have this entire security posture dashboard. I'm just going to check real quick, by the way, in the background to see where we are on my creation here. My cluster's still creating. Hope so. So are yours, I guess. So I'll just keep talking. And so here we have basically workload configuration. So we have things like pod sharing a host namespace, some things running as root. So we do nice things like any security bulletin that's relevant to just your specific clusters. We publish those, different severity and threat. So again, this is just kind of nice features that we have sort of built in, and we give you that across the sort of the entire kind of fleet. If we, I'm sorry, I should have shared a tab there. If we go back over here while we're waiting for our, we're still creating our clusters. The other nice thing is we have kind of a GitOps as well, where we can specify a bunch of packages stored in any Git compliant repository, and we'll deploy those across clusters. But these are kind of the cool ones. We also have overall kind of utilization things like across the overall fleet. You can kind of see how well you're doing. So for example, we're not doing very well from a utilization perspective. We're wasting probably some of Google's money here. We've requested 165 CPUs, but for example, we're only using 28, right? And then, okay, well, where are we using most of these? Oh, these are the sort of top CPUs, right? Then we can drill down into individual ones. So we have a ton of these, fleet level kind of metrics. The other nice thing, and when we get into this, well, it's nice, I think, for people who run the platform, maybe not as nice for, but also good for individual teams too. So the other thing is, we're going to cover this later, but teams where we kind of divide you up into different groups and we basically use namespace-based tenancy. The other nice thing at the sort of fleet level, we can actually give you things on sort of like, team efficiency as well, right? So up here, we kind of saw, well, we're not doing so well. We can see which clusters we could drill into, and then we can actually get down into see, which kind of teams are actually, doing well or doing not. From their sort of overall like utilization. We have 3 specific teams here that we've configured. So yeah, again, these are kind of a lot of the things that you may use other third-party tools are sort of built in. We've just tried to add these in.
So Gary,
yeah,
we have a question in the chat that asks, are you able to export these specific metrics to third-party tools? So that way they can bring them into a unified view.
Yeah, all the metrics. So by default, so many of those metrics are on those dashboards themselves are built-in ones that we've kind of collected as system metrics. But you have a couple of options. You could either pull them directly out of like cloud monitoring if you are already using that. Google Cloud Monitoring, and it for example already has a Prometheus API, so you could log that into sort of Grafana. Generally, if people are using third-party tools, you may replace, like, for example, one of our agents, for example. So we have built-in things that are, for example, collecting like cAdvisor and other things. Those are all internally. You could run your own agent or scraper that's actually pulling metrics from those and directly exporting it. So we have people who do both. Some people still collect all the metrics on our side and then just export them. Via the API, or others simply don't use our dashboards, for example, and then use their own collectors and we make those same metrics available from other collectors as well. And those are all, we have those in the documentation. Great question. All right, let me go back here and see how we're doing. Hopefully you guys are seeing a little more than me. I guess I am still creating my my clusters here. Hopefully it shouldn't take too long. All right. All right, we'll go back over to Gary talking mode. Let's see. So what else are we going to? Let me share this tab over here. A couple other things just to kind of show you that what's in here. We'll cover this. Yeah, we'll cover some of these. We'll cover the teams and things. Let's see what else we have. A couple of other interesting, pieces that we have in here, which we're not going to talk too much about. Where is it? So we'll talk a little bit. I'm just going to go into this sort of config area. So again, you have the option. You don't have to use this. We have people who use Argo and Flux and other tools. I mentioned that we have a built-in capability which we call config sync. And config sync, takes the GitOps model, right? So you're subscribing. So essentially, you're storing a bunch of artifacts, whether that be network policies, secrets, applications, YAMLs. It could be any type of OCI compliant image. It can be all other packages. You're sort of storing those in GitHub, or we actually support pulling from artifact registry as well. And you're configuring it so that each cluster is basically going to use those repositories as a source of truth, and it's going to continuously reconcile to those. So this is a great way that, for example, if you are, have a standard way of creating a cluster, you've got a bunch of core packages, like a bunch of core network policies, a bunch of controllers, whatever, a bunch of standard things that you want to run in all clusters. If you set all that up at this fleet level, then now let's say you have to provision, or even have another team, provision their own cluster. When it actually joins the fleet, it's automatically going to get these settings, like to use this config sync, to sync to these policies, and automatically become in sync with the fleet, right? So again, you have this sort of built-in way to make sure that any sort of enterprise practices or platform practices that you've set up, that you can bootstrap your clusters with that. There are other ways to do that as well. You could obviously just have an IAC script and do it yourself, but this is kind of nice because now we're getting this sort of continuous, reconciliation going on for these types of artifacts. And you can see, going through the dashboard here, we have these concepts of packages, which are essentially how you kind of can group different artifacts and applications together. And we'll take a quick look. We won't do this in the lab, but you can kind of see, for example, what do we have from a settings perspective? Do we set up auto upgrades and other things? So each individual feature kind of has its own collection as well. All right. Hopefully I have all around here. Oops. All right. We should be. So hopefully everybody sees something like this that says running. I think we also tell you to, you can also run a command just to make sure that both clusters are running. In general, they should have created at the same time. We just need to run gcloud containers. Actually have the command here just to make sure that your direction is working here. Container clusters list. Hopefully, the main key here is to show that both your clusters show status of running. All right. So hopefully all that worked. So now we've got our two clusters. Now we can actually have some more fun. Hopefully we've checked our progress here. We'll just do that. Awesome. We've made it through creating our clusters. So now, I kind of took you on a quick tour earlier of all these sort of fleet level features that you could enable. I talked about config sync. We do have the ability to install a managed service mesh and a few. And I talked a little bit about security posture. One of the things that we're actually going to do, you can enable the mesh. We don't really use it in the lab, but feel free to. What we're kind of showing you here is you can enable things via the UI. They can also be enabled via Terraform, or in this particular case, we're enabling it via the CLI. So this is just kind of showing you how we can kind of enable a feature at the fleet level. And now when we've enabled it at the fleet level, that means that we can make it available on the we can make it available, to the individual sort of clusters within there. So we'll just do this. And this is just a simple sort of command line. So all we've done here is we're saying that in our platform, at our fleet level, we want to basically have the service mesh feature should be enabled. So anybody who wants to use it is able to use it. All right. So now this next step, and you guys can follow, I'll just do these things up in here. Hopefully I follow them the right way while I'm back here. But essentially we're going to go in and we're going to configure our policy controller, which is basically a managed version of Gatekeeper, OPA Gatekeeper. And we have a ton of built-in policies that you can kind of configure. So what we're doing here, so you can kind of scroll down, you can log out of the shell, or you can kind of just scroll this down a little bit if you want to, and then you can scroll back up later. So we're going to scroll down here to all the way down in the menu here under GKE. We're going to go to the feature manager. Hopefully. And then we already kind of enabled we've made the service mesh available within the cluster. We just haven't enabled it on any clusters. We've got security posture, config sync, and then you're going to scroll down to policy.
Gary,
your screens may be different. This kind of like auto sizes, so they may not all be stacked in a row. And then we want to configure. Yeah.
I think you need to switch tabs again.
Oh, damn! I did it both times.
There you go. Better. Thank you.
I was on a tab that had that, but wrong tab. So, all right. So feature manager over here. Scroll down to policy, and then you're going to hit configure here. So now what we're just say got it. Don't hit configure. One thing, don't hit configure here yet. So then you're kind of scroll down. We give you a bunch of like overviews of like what we're actually talking about, the benefits of running multiple policies or having policy applied at the fleet level. One of the things that we can do, we're going to customize our sort of fleet settings here. So we have a ton of built-in policies for all kinds of compliance, CIS benchmark, NSA hardening benchmark, pod security standards, things like NIST, policies for DSS, a policy, some best practices around cost. We have a whole bunch of them. You can feel free to enable whichever ones you want, but for the purposes of the lab, I think we're saying, enable the pod security policies v2022. So now this means that this is going to be for any clusters. Once we decide where policy controller is going to be deployed, this is going to be the default policies that are going to be enforced by that. So we'll hit save changes there, and then we can hit configure here. So now we've essentially said for our platform, we're enabling the policy controller, and here's all the policies that we want to have enabled. So as this kind of goes through, hopefully. So again, this is kind of a fleet-wide sort of setting. And then once that's complete, you'll come to this sort of screen here, and you'll see here right now that we have none of our clusters have it enabled. So one of the things that we want to be able to do here is just go enable it for. So we're going to say, here's our clusters, and then we're going to sync these to the fleet settings, which was to run policy controller and enforce those specific policies. So now we're going to hit sync to fleet settings. We'll say confirm, And this should take a couple of minutes as well. Hopefully not too long.
I think one thing that is interesting about the lab here is that we're running an autopilot cluster and a standard cluster. Can you talk about those a little bit more, Gary?
Yeah. So yeah, as I mentioned, earlier, yeah, we did decide to deploy sort of two different kind of clusters. Maybe we'll just show it this way. I'll go over here to in the essence of creating myself with yet another tab problem. Actually, no, whatever about that. Actually, I'm just going to do this. Sorry. Yeah, I'll just talk so quickly. Yeah, we have about in 2021. We thought to people like, hey, Kubernetes is great. We really want people to kind of run this stuff in the cloud, but maybe we could do a better job of making it easier to run Kubernetes for you, and hence GKE Autopilot was born. And the unique thing about Autopilot is that we took a different approach to how you manage the underlying workloads and compute. So instead of having to provision node pools yourself and manage nodes and size nodes and manage bin packing and figure out all the best security settings and lock down all this stuff, we said, hey, what if we went to a model where you just deploy pods and we figure out the compute underneath the covers, but you only pay for the compute that your pods are using, right? So your pod requests 1 CPU and 2 gigs of memory. You just pay for 1 CPU and 2 gigs of memory, even if whatever that's deployed on underneath the covers, right? So that was this notion of this pod-based billing model. We also decided to have a kind of a unique proposition that we would actually monitor and give SLAs for potentially for workloads and sort of availability time. And we also took, pretty much all of the best practices that we knew from our Kubernetes hardening guide. A number of other, let me just go back to sharing here, a number of other, features and built those into what we call Autopilot. So definitely, the way to go. And then about a couple years back, we made that the default cluster type as well, because we really wanted to focus, we really wanted customers to focus on running, workloads, not on actually having to run like Kubernetes itself. Now, for those of you who love Kubernetes, as all people should, and really want to tweak low-level settings, manage your nodes yourself, have some semblance of more control of your nodes, then we also have GKE standard mode. I guess I will mention that we announced at our conference in Vegas, and we should see this in probably August, September timeframe. We're kind of combining both of these kind of modes together. So this sort of fully managed pod-based model and the sort of standard node pool model, we're going to merge those together as well, so that you can run both together if you want to. All right. Hopefully, did I? Sorry, I'm sharing this tab, right? Yeah. Hold on here. Let's double check what I actually did here. Hopefully, mine should have been here. Configure. Nothing here. Sorry. Down here. All right. Let me just double check where I was here. There we go. So hopefully everybody can see my screen. I think we should be good here. So I think we should, I now have, sorry, my thing needed to refresh a bit of, all right. I should be sharing this tab. Right. Okay. I'm back in. Clusters with policy enabled. Should be good. Right. So now if hopefully everybody saw that, that should be about the right amount of time. Let's go back here. Sorry. All right, so we've gone through, we've synced our fleet. So now this is pretty cool. So again, as I mentioned, similar to, so we'll just check our progress here. So now this is pretty nice, right? So we've got our clusters joined, both autopilot and our standard cluster. We configured them to be part of a fleet. And then we've also configured policy controller. So they're going to enforce sort of the best pod security practices as well. And now we'll come to kind of our, so that was kind of just some core kind of basic stuff that you can do like across the sort of entire platform. Now the next part is about teams. Again, you can kind of, read this. The idea of teams was, well, we know that there's multiple development, a lot of times people run multi-tenancy, and you can either run, you can run a cluster per tenant or cluster per application, or you can try to run, multi-tenancy within a single cluster. Typically people will use, namespaces for that type of isolation. So and then you want to set up things like role-based access control that, this particular set of users who's part of this group, they can only access this namespace, but nobody else's namespace. So we found that lots of people were building this or using other kind of third-party things. So we kind of came up with this idea of like teams and scopes. And we said, well, we like, having, a scope and RBAC, to kind of a team or a group of users. We like, assigning users to namespaces, right? And you could have teams or whatever could be part of one or more namespaces. And then, namespaces can be in clusters. But what we decided to do was we said it doesn't really matter if you decide to have like 5 teams, 5 namespaces in one cluster, or 5 teams, 5 namespaces, and each of those namespaces is in its own cluster. Let's support sort of both models. And that's really what this sort of abstraction layer does as we kind of go through it. So we're going to kind of go through here, and I just need to remember the names here. The basic steps, you'll follow along. We're going to go in, and we'll go to teams. We'll create a team scope. We're going to create this thing here. We're going to create, a dev team here, and then you'll want to know your student name because you're going to add yourself as an admin of that particular one. So, all right, I got this right, Ben. Hopefully, I'm sharing the right screen now. Ben keeps me honest here. So we're going to go down to here, and it's up to here, up on the top. We're going to go to teams, and then we're going to create a team scope. So the idea is that, as I said, a team. So we're going to call our thing GCC, dev team. We're going to add a team member. And the nice thing is, so team members can be users or groups. The groups would be, depending on how you set things up here, we're set up to use Google Cloud Identity. So it would be Google Groups. But if you were using a third party, it could be those sort of third-party groups. We're going to select type as our user, and then you're going to want to, you can actually just copy your student username, but I guess if you go back over to here, it just basically tells you to, type this, but I'm lazy, so I'll attempt to copy it. And then we'll just paste that in here. So now we're just sort of adding yourself, your lab user as that. So we're adding that as our user or group, and because we're in charge, we're going to make ourselves the admin. There's 3 scopes. So an admin can now, once you're an admin of this scope, you can now add more users, configure namespaces, etc. An editor will have write access to any of the resources that are kind of in here, and then a viewer will just be able to, for example, view resources at, say, the cluster level. So we're going to hit continue here. You can now select, within this sort of scope, you can see, where do we want this to apply to? In our case, we're just going to pick both because we might as well. But for example, you could decide that, some teams only have access to, a couple of, cluster 1, and some have access to cluster 2, etc. So we'll just do that, but we're going to give them both because why not? And then this is where the nice thing is, we're going to create this sort of namespace. I forgot what we named it, but we called our namespace something, GCC dev namespace, if you go back to the lab instructions. So we'll just do that. There we go. So GCC namespace, we've added that. And now we're going to create our sort of team scope. So in the end, what have we done here? We basically said that team, GCC dev has access to, 2 clusters, and has this manage this namespace GCC dev NS. We're also, so underneath the covers, what's really happening while this is creating, we are creating that namespace as a managed namespace. We will create that namespace on both of those clusters. We will also create the RBAC rules for the roles that we said. So an admin who can, have do anything, an editor who will be able to create resources within that group, within those namespaces, and a viewer who will be able to just sort of view within that. That's all going to be handled. So what we'll have already done underneath the covers, we will have created the role binding, the role binding, handled all of that for you. And so that was what was actually happening in that sort of provisioning step. All right. Hopefully everybody's good there. And then, after the fact, you'll be able to go in, but we'll cover this a little bit, but you'll be able to, see the clusters that are in their namespaces, logs, etc. All right. So now we've got all of our infrastructure hopefully set up. We've got our team set up. We're going to check our progress. Hopefully I'm doing this lab correctly. All right. Setup completed. And then finally, okay. So the ideal world, the platform engineering team would have done all the work that we just did and everything was set up. So now in our final step, we're actually going to deploy an application. And the goal here is just to show that that we'll be able to, one, that we have the rights to deploy the application to this kind of namespace. And then 2, that we have scoped some of the logs and other things like that in the team view to just that application. So to deploy this, we'll go back to our Cloud Shell environment. We need to get, we're going to use kubectl to deploy the application. One of the things that we need to be able to do is get our credentials. So you can copy and paste that command, gcloud container credentials. So it's going to log me in. This is basically creating your, adding the credentials to a kube config underneath the covers. And I think we did it for the AP cluster for a deployment perspective. Oh, sorry if I didn't show that. So gcloud container clusters, just paste it there, run that. You should see this, and we've generated our kube config entry, as we stated. And then we just need to run a couple more. We need to run a couple more steps here to get our app deployed. So step here, deploy an application to our team. All right, so we're going to deploy our application here. So once we've done that, I guess they're going to have us. I don't think you necessarily need to run this second step here, but feel free to. We should always follow. I guess if there's one thing I've learned is always follow lab instructions. So we'll just run this. We'll just run this paste. Sorry, come on. Sorry. File this command list. So I'm going to just copy this command here. Sorry, I did not do that. Copy that. And this was just renaming the ugly context that our default generated context to make it into whatever. Oh, I already renamed it. Okay. So now we're within that sort of context. Now we're just going to get our app. Then the nice thing is you can, after the fact, this particular application just exists up in GitHub. It has, if you go to that repo later on, it has a bunch of instructions on how to deploy it in like multiple complicated ways. You're able to, deploy it with, database services, with a service mesh, other advanced things. In this case, we're just going to kind of pull it down and do the most basic deployment. So I did my git clone. You can just copy that command. And then all we really need to do, as you can sort of read from the lab, we're just going to, you can copy the next command. And all that's really going to do is deploy a couple of artifacts onto the thing, one of them being the actual application itself. So hopefully you took the next step, and you can see here, we're just using that context that we created. We're applying a secret, which is used by one of the services. And then we're just going to apply everything that's in the manifest folder, which you can check out at a later time, which has a number of basically microservices. And we're going to hopefully deploy those all into all right. Let's make sure I don't know what my context was. Okay. So hopefully we deployed that. It's going to tell us to wait for a few minutes. Hopefully most of you are. We can just do. What was it called? Yeah, that command, by the way, yeah, you can just run. If you didn't see that, it's just watch kubectl -n. Our namespace was GCC dev ns, and we're just going to list all the pods. And this, for those of you who aren't Linux folks, hopefully everybody is. The watch is just refreshing this command every 2 seconds. So right now, what's happening under the covers? And by the way, this will be, we're making this even quicker. There is a little bit of work. As I mentioned, we don't have any, we didn't have any pre-configured compute or anything like that. So as we're sort of going through this, the application itself is actually deploying here. I hope. Great. So you can see, hopefully you start to see this as well. Our containers are creating. All of our services are up and running. And you should end up with all these microservices. And you can see this application itself, a typical kind of commerce kind of front end with a bunch of kind of apps, accounts, balance, ledger, etc. Feel free, definitely, later on to play around with that sort of application. And then I think the last thing that we wanted to be able to show. I don't know why. Oh, my lab. Oh, there we go. Sorry. Here we go. Where am I? All right. I'm going to check my progress here. Hopefully everybody's here. Come on. All right. We're good to go there. So the last step. So now we've done a pretty good job. We've got everything deployed. We've deployed this into our namespace for our specific team. And one of the other nice features that we added in was this idea of how do we handle things like multi-tenant logging. So commonly, right, because all these clusters maybe in the same project, all the logs typically go to maybe a centralized monitoring bucket. But what if you just want to, and because in Google Cloud, we have GKE and then we have cloud logging, a little bit two separate things, but well integrated. We needed to figure out how do we create a nice view for you such that, people who are in GCC dev team can only see the logs for the namespaces or for their scope, right? And so, and in Google Cloud on the back end, the way this works is you'll have different buckets. So everything will come into a main cloud logging, and then we'll filter things to source and syncs to specific dedicated buckets for teams. I mean, you can set all that up yourself, or the basic concept here, as you can see here, is that we're just going to set up the logging config and from the scope. And the way this works is there's basically just a config that we're setting up sort of fleet-wide. The basic notion here is we're going to still leave all the logs in the main logging for like the Uber admins or the platform engineers to be able to look at. But then we're also going to copy or move. We're going to create dedicated logging spaces for each particular team and its scopes. So what this command is doing, we're just outputting the config, and then we're going to apply that at the sort of fleet level. So I'm going to copy that here. Just going to Control C out of this step here. share our little step over here. Oop, I don't know what I just did there. Apparently I did not copy that. So I'm going to copy this over here. We'll paste this over here. All right, so we're just creating our file, and then it's going to deploy our config. So as I said, this is the kind of config that's, we're updating fleet observability, and it's basically going to set up that config, and then it will set up those sort of buckets that are in there. And so now, if all has gone as planned, so we've set up our fleet terms, we're going to go, we're still back in our, just double check. You would have come in here. You basically only see, the scope that you're in. We're going to click on our team scope, and hopefully, we'll click on logs here. And in this, probably doesn't exist yet, so it can take a bit of time to sync, but that should be basically, yeah. That's we'll get there. We'll get there eventually. I forget if we have timing on here. Yeah, it can take 2 or 3 minutes to sync in the logs here, but just sort of keep refreshing. And as I said, you can see now the interesting thing about this error is you see that what we actually did is we ended up creating a dedicated bucket for. If I make this a little bigger, we created underneath the covers. We ended up creating a dedicated bucket for these particular logs for this particular scope, and they're all kind of going there. So hopefully I won't refresh, but I'll let folks kind of do that themselves, and you'll be able to see those sort of logs scoped to you. We're just going to see if we set things up correctly here. Hopefully I did. All right. And then, yeah, I think that's kind of it. So, just if we take we'll give it one more shot here, and then I'll let you guys do it on your own for a few minutes. Yeah, cool. Nope, not yet. All right. It'll come. It'll sync eventually. So what have we done? What did we kind of do here? Just a quick tour on the overall lab. Hopefully, everybody remembers since we just did this, but we came in, we created our fleet. The nice thing is, if you had more fleets in your project, you'd be able to see that. We can now see that in our thing, we have 2 fleets in our cluster. We haven't really started to get billed yet, so we don't know our monthly cost. But we can kind of look at, we automatically had some security things. We've got our policy status configured across multiple clusters. We didn't do config, etc. Now we came in, we also created our team. And so we've kind of done 2 things. We've done the platform infrastructure, and now we're doing sort of the team infrastructure on top. We created our team scope here. We assigned it. We said that this team scope will be applicable across a couple of clusters. It's going to be applicable to this particular namespace. I'm just going to go over here and, yeah. It works at some point. Don't worry. We'll come back to this if there was an error, but you guys get the picture. And then lastly, we do have the ability to look at the things at a scope here as well. But we also had these were all the workloads that we actually deployed, and we'll be able to see those as well. You will see, for example, that we did deploy like a gatekeeper and a few other things, which are the components of policy controller, and the rest are our application.
Cool. Thank you, Gary.
We should be at the end of our lab. Hopefully the lab worked for everybody.
Awesome. Well, thank you so much. At this point, I'm going to share just a couple things and we'll wrap up the session here. Huge thanks to Gary, Ameenah, and Shobit for doing this. I think if we step back here, Gary did a great job of running through like you said, the fundamentals of like how can we use GKE and the features in GKE to, build the scalable platform. And then if we combine that with what Ameenah and Shobit, demonstrated from how do we build the developer experience that allows our application teams to build and deploy applications, do canary deployments, actually see these things and do it in an autonomous way. And then, like Shobit demonstrated, creating an abstraction where our engineering teams can manage their secrets and their passwords, taking that burden off of other teams and just building it down into the platform. I think that we can create, this reliable, scalable platform with these repeatable golden paths. The labs will remain available to everyone for the next week. So please do go to explore.quicklabs.com. Run through all 3 labs. Like I said at the beginning, we condensed 3 hours worth of labs between what Gary took us through and what Shobit and Ameenah did. It's really 3 hours worth of working through the console and seeing how these things come together from a platform engineering perspective. So please do go to explore.quicklabs.com. Go through all 3 labs. If you have any questions, feel free to reach out to any of the 4 of us. We'll be more than happy to email or chat with you all. So please do that. That's pretty much it at this point. So thank you everyone so much for the time. Hopefully you found this useful, digging down into what some of the things that we can do in Google Cloud, and then building things on top of this infrastructure to really make our internal developers' lives better.